Hello and good afternoon. I'm Solly Ross. I work on metrics and monitoring and pod autoscaling and a whole assortment of other stuff at Red Hat, and I'm the SIG lead for SIG Autoscaling, one of the two.
And I'm Maciej Pytel. I'm a software developer at Google. I work at both pod and node autoscaling in Kubernetes and GKE. So let's get started. And I wanted to start this talk by telling you about this cool app I wrote for serving some data to our customers. It works, it delivers data. It's pretty fast, as you can see by the blurry background. And I really like it. And it turns out other people also like it. So they started using it a lot. And now it cannot handle all the load. So I guess I need to scale it, and I have some vacation time coming up, so I need to do it quickly. Sorry, can you just help me here and walk me through my options?
Yeah, so you could create more replicas of this application, which is great if you don't have a ton of state, and you can just create more, and they can all handle your traffic. You could also scale a single instance of that application up, make it beefier, give it more RAM and CPU, which would be great if you have a lot of state and it's not easy to scale out.
Sure, that makes sense. So I think I'll go with the more instances options, because that could require some minor refactors to my app. So let me just update some configs, and I'm good to go, I guess. And it's done. It's working now. Everything's fine. I can go for my vacation, except that happens. But that's, yeah.
Dude, by the way, there's like more people using your app now.
Yeah, exactly. But I got this. I'll just update a few configs, and I'm good to go. So that's it. I'm done. Thanks. Yeah, I really wish there was some sort of a machine that could do that for me, do this repetitive step of updating config to scale automatically.
It's a really good thing you're working on Kubernetes then.
Yeah, we have this concept of autoscaling, and the concept is really simple. It's just adding or removing resources as required by your application. As you may have guessed from our story before, we think about two kinds of autoscaling. So horizontal is adding more instances. And as Solly said, that works pretty well for any stateless workload. Maybe like serving workload is a usual example.
Workers pulling from a work queue, web servers, things like that.
Yeah, and then we have vertical scaling. And this is basically making your instance bigger or smaller based on the resource usage. And this is better for sort of state-heavy applications that you just cannot replicate easily.
Things like a database or Heapster, for instance.
Oh, yeah. So if you want to learn more about vertical autoscaling, we have a SIG Autoscaling deep dive tomorrow at 4:25, and that's where we're going to talk about that, among other things. And in this presentation, we'll focus on horizontal autoscaling in Kubernetes. And so it's going to be about Horizontal Pod Autoscaler, or HPA for short. And basically what HPA does is it changes the number of replicas based on the predefined target and current load. And it has been available for a while. I think V1 was actually G8 in like 1.2 time frame. But it's pretty limited. It only supports CPU-based autoscaling, which is pretty cool, but also not enough for many applications. So we're now working on V2, which supports custom metrics, and this is currently in beta. So how do you use HPA? As most things in Kubernetes, it starts with a YAML, and here is this YAML, or as much of it as I managed to put on a slide, but it's not much longer. The important things that you need to define is really basically what you're going to autoscale. So this is a reference to your deployment or replication controllers, stateful set, whatever you want to autoscale. Minimum and maximum number of replicas. So you're asking HPA to set the number of replicas based on the load, but please do not go below minimum or over maximum.
Don't want to run out of space in that shipyard.
Oh, yeah. And then there is the target CPU utilization. And that's basically how much CPU you want to use. It's a percentage of resource requests defined by the pod. So I would say the usual number would be like 60 to 80 probably, and that's so that you are actually having a well-utilized cluster, but you also have some safety margin going on. And that's basically how HPA v1 looks like. So let's see v2. And it's actually pretty similar in many aspects. I mean, all this stuff is basically the same. One thing that has changed is now, instead of just assuming it's CPU, we actually have a resource name in here. And currently, you could use CPU or memory, but this is more a matter of what metrics are available than actually just HPA implementation. And because it didn't make sense to have a target CPU utilization if you can have other metrics, that field is renamed. And that's about the changes here. Yeah, so now let's try this thing in practice. So I basically have... oh, yes, that's a good idea. How do I do that? Is that better?
You guys can all see that well?
I'll take that as yes, and I hope our network is working as expected. Oh, yes, I have it. So I have a cluster setup where I have a sample server application. It's not doing anything much. I can actually curl it, and it will print OK after doing some CPU burning calculation. And I have some pods already hitting it, so there is some load on this thing. So let's try to autoscale it. This is basically the YARN for the HPA. As I said, it's not much larger than what I've shown. And I've just created it. And now we can see how it works. So the deployment started with one replica, which maybe I should have pointed more explicitly. It actually has already been scaled up by HPA to 3 replicas based on the load. So this is the actual load. It's 168%. We wanted 60. So 3 replicas would be a pretty good approximation. And that's done as far as this part of the demo goes. Let's quickly go through what just happened and how does HPA work. So basically, we have a built-in HPA controller in Kubernetes, and it monitors all HPA objects that you may have created. And for each of them, basically in a loop for each of them runs a simple bit of logic. Just get the metrics, use the metrics and the predefined target to calculate what would be the appropriate number of replicas. And if the actual number of replicas is different than what it calculated, just update the number of replicas so it matches the calculated value. And that obviously leaves out the part of how is this desired number of replicas calculated. And it's really simple. I mean, it looks kind of like math, but if you actually think about it, all we do is we just sum up the utilization of everything to get the total utilization. We divide that by target. We get a number of replicas. There is no thresholds, no something special. It's basically just that. We do that every 30 seconds by default and just apply the result. And there is just a bit of heuristics for dealing with starting up pods.
So for instance, if, say, you had a target of 50%, you were using 100%, 100 over 50 is a factor of 2.0. And if you have 2 replicas currently, 2 times 2 is 4, so you get 4 replicas as the target.
Right, but we have more metrics, and I think we sort of promised people custom metrics. So
we did, didn't we? I was going to end the presentation here.
I mean, that would be pretty lazy of us.
It would be. Thankfully, we're only a little bit lazy. All right, so you might have noticed that before, when the new form was introduced, that this is actually, the metrics field is actually now a list. And what that means is we can actually have multiple metrics entries, and each metric entry can have a different type or the same type in some cases. And the Horizontal Pod Autoscaler controller will calculate the target replica count for each and then choose the highest one. So here you can see we actually have 2 metrics. We have the resource metric that we had before, so CPU. And we have a new type. This type is called pods. Now, pods acts very similar to the resource metric type. So we're looking at metrics describing each of the pods in the target of our horizontal pod autoscaler. So all the pods in our deployment, for instance. And so what we do is we go and we get this custom metric. We're going to say it's like HTTP requests per second here. And we fetch that value for each of the pods currently in our deployment. And then we average that value up, and we compare it to the target average value that we want. So here we say 1 request per second. And then we compute our ratio, like we discussed before, and use that as a multiplier. So let's give that a try.
Yeah. So I'm just going to patch our existing HPA object and add this pods metric to it. And now we can just watch the result. Yeah, I mean, it needs a while to grab the metrics, right?
Should be going a little faster. Maybe something's wrong.
Yeah, I mean, that looks kind of suspicious. Let's try to maybe
see if we can figure it out.
Yeah.
Oh, I see. We have a problem. Let's go over how we figured this out.
Yeah.
So if you're familiar with Kubernetes objects and the underlying structure of them, you'll know that when you want to see what the current state of an object is, you look at the status. Just like when you want to specify what the state should be, you look at the spec. So let's take a look at the status for a horizontal pod autoscaler object. So we have pretty much what you'd expect here. We have our desired and current replica count from the last time we calculated them. So at our regular interval, we can look at our current and average utilization. So like that's the percentage we discussed before. And we can look at our current average value, which is the raw value that it's using to calculate that utilization. But what we really care about here is conditions. Conditions are a way of saying like what the current state of the horizontal pod autoscaler is and whether or not something is blocking it from working. So if we take a look at the conditions we have here, we have two. So if you two conditions. So the first one is telling us we're partially copacetic here. We were successfully able to fetch the scale of the target we're trying to scale. But then we got to trying to actually fetch the metrics, and we failed. We see status false. And the reason, which is the reason for robots, is failed get pods metric. And if we look at the message, we can actually look at the message in the real case.
Yep.
And we'll see, we say the API server is currently unable to handle the request to get pods.custommetrics.k8s.io. So that means we are missing something. We are missing something to serve our custom metrics API. So for CPU and memory, we can get them from something called the resource metrics API that's served by metrics server.
And that's installed by default, so you get it out of the box. But for custom metrics, we actually need something else.
Yes, so we need an adapter. So this is a special API server that kind of acts as a front in front of your monitoring solution. So it sits there, and it takes an API that Kubernetes understands, and it turns that into requests to your monitoring backend, queries to Prometheus, requests to Stackdriver, what have you. And then it takes those responses and transforms them back into objects that Kubernetes understands. So there's currently two open source solutions out there. There's one for Prometheus, so the whole thing is open source. And there's also one for Stackdriver that sits in front of the Google Cloud Platform monitoring solution. And there's actually a third on the way from SIG.
Right, so you actually need to explicitly install this adapter for yourself. So let's basically do just that right now.
So we'll be showing you the Prometheus adapter today?
Yes, we're using Prometheus metrics. And it actually takes a few seconds to load. And I wanted to use that time to maybe go to one more or maybe two common misconceptions that I have seen people struggle with. So the custom metrics actually have to come out of somewhere. So in this case, we're using HTTP request. It's not something built in. My simple server just has an endpoint that exposes these metrics. I'm hitting different replicas to load balancer, which is why I get different numbers. But yeah, basically that's what we need. And it should have started by now. So let's see it. And we have the result. And another thing that people find confusing is this. So this is basically the desired value. Same as with CPU. This is the desired value. We actually set it to 1 query per second. And this is the measured value, which seems to be like over 1,000. But this M here says it's milliunits. So basically, it's a Kubernetes way of representing fractions. Any fraction will be written as like it will be given in milliunits. So this is actually just one. Like this is almost one basically, and this is because while we were talking, HPA already scaled up from 3 to 6 replicas, and as you can see, it managed to match both targets pretty well. So it's basically doing its job.
So for those of you who are familiar with the difference between floating point and fixed point, this is kind of a fixed point representation. So we go out to milliunits when we need it, and when we don't need it, if it's 1 on the nose, Kubernetes will just not display the extra zeros and will just collapse to a single unit.
Right. So this would be basically the pod metrics, but we have some more stuff, right? Yeah, we already shown that.
So one of the interesting things we can do here is we don't actually need to scale on a metric describing the pods in your target deployment. So for instance, you might be measuring some sort of latency on a load balancer that's measuring like on a per service basis instead of on a per pod basis. And so for that, we use the object metric type. Now the object metric type looks kind of similar. We specify a metric name, like we did before, but we also specify a target. And so this is the object that's being described by the metric. So we say, for instance, here, we're measuring request latency on the sample server service. And we set a target value. It's not an average, because we're only describing one object here. So let's try that out.
So let's patch the HPA once more and basically add the object definition. That could be faster.
So while that's going through, we have a little fake load balancer I wrote, and it's just measuring latency on HTTP requests. And one of the neat things is, with this particular setup, note that we've been describing metrics as describing a particular object and not coming from a particular object. So we can have this load balancer that is exposing metrics about a particular object. And that comes down to how things are stored in your monitoring pipeline.
Right, so when we describe our HPA, right now we can actually see the value and target for each metric. And I set the target for the latency unrealistically low, which is something that you should maybe watch for, because basically my server is way slower than that. And however many replicas we add, we will actually not go down to 10 milliseconds. So we will end up reaching maximum at some point.
So I'd like to point out, the HPA will actually tell you this. We can see we have a third status condition over here, and that's called scaling limited. And the scaling limited status condition triggers, normally it's false, and if it's false, everything's copacetic. If it's true, it's an indication that you're either running up against the limits, or you're on your HPA, or you're in a back-off period. So if you hit this, and you get like something like too many replicas, that might be a good indication that perhaps you should consider adjusting your targets, or maybe you just actually have that much load and you need to consider increasing the limits on your horizontal pod autoscaler.
Right, so I think that's it for the demo, but we have one more type of metrics.
All right, so we recently added this new type of metrics. These are called external metrics. And these are useful when you have metrics that don't describe an object in your Kubernetes setup. So this often happens if you are running on a cloud provider and you have integration from your cloud provider's monitoring system. So for instance, you're running on Stackdriver, and maybe you have a pub sub queue, and you have some application on Kubernetes that's consuming messages from the pub sub queue, and you want to scale on how quickly items are being taken out of the pub sub queue and how much backlog there is, for instance. Well, that pub sub queue isn't necessarily associated directly in the monitoring pipeline with a Kubernetes object. So you'd use an external metric. And so we have a metric name, and we have a label selector. And so this is just similar to a standard Kubernetes label selector. You all know and love them, hopefully. And that gets translated into a query to the monitoring pipeline to select this metric.
Right, and it's currently supported in, it's only in 1.10, and it's only supported for Stackdriver right now, which is why we're not showing it. But it works there, and I hope it will soon work on Prometheus as well.
And notice that unlike object metrics, we actually have two options right here for the way we specify our value. And that's something I'll talk about in a moment. But we can see we have target average value. And the way that works under the hood is that we just divide the metric by the number of pods so that you can set a value on a per pod basis, even though the metric isn't necessarily describing the number of pods directly.
I like QPS as an example here, because if you have a load balancer that's measuring QPS, it's much more convenient to say, I want 200 QPS per pod than to try to come up with desired value for that metric. Right, so I think the last thing we have is basically our plans for the future.
So one of the things, like I just mentioned, the only thing, external metric has that little advantage there. A couple of advantages, the label selector and the target average value. And so we're going to be bringing those to object metrics. So you're going to be able to drill down further into a particular series. So if you have, say, already have a metric broken up by HTTP requests on your of request latency, and you actually just want to scale on GET requests, or you want to scale on GET request latency different than POST request latency because, I don't know, maybe you have some different constraints on those two. Currently, you can't really do that easily, but we're going to be adding the label selector in so you can say, method equals GET as an additional constraint on which metric you select. And we're also adding target average value to object metrics so that you have a couple more options on how you break up your metrics depending on how your targets need to be structured. And we're also considering a little bit of a cleanup to help unify some of the metrics targets together.
And I think that's it. Thank you. Do you have any questions?
That's the resources slide, just so we can connect more.
Yes.
So if you are curious to try to learn, if you want to learn more information about this, if you're curious and you want to reproduce the demo code is available at that repo up there. You can also take a look at the official Horizontal Pod Autoscaler documentation for more information on consuming this as a user. And if you want to stand up your own Prometheus adapter in front of your Prometheus instance, the repository is there.
Right, so back to the questions. I've seen a hand there.
Hey there, thank you for the demo. Do you plan on doing I would call it a short circuit, so you don't need an external monitoring system, but you can get on a per pod base, a simple metric that you can scale on or react to? If a single pod reports some arbitrary value?
Mm-hmm. Do you want to take this one?
So we had a similar model once upon a time. Metrics were exposed by cAdvisor and then went up through Heapster. And it turned out not to work very well. And it also turned out that a lot of people actually already had a monitoring system in place, and they really didn't like the idea of having two monitoring systems or having to shuffle data between them. And so we decided that the easiest architecture was just to say, all right, you can use whatever monitoring system you have, because Kubernetes is not necessarily itself about collecting those metrics. So use the tool that's really good at collecting metrics and transforming metrics of your choice, and then just teach it to speak this standard Kubernetes API in the form of an adapter, which is a really long-winded way of saying no. We're not going to have that short-circuit option.
What metrics are you using, which are maybe not
for the custom metrics, I think queue length, pending messages in message queue systems, are a pretty popular choice.
Yeah, we get a lot of requests for how do I scale on work queue numbers, queue length, queue ingestion to egress ratio, stuff like that. We also get a lot of, how do I scale on my HTTP requests? Like I've been getting that question since basically Horizontal Pod Autoscaler appeared. So those are the two big ones. But I've seen a smattering of other small ones too.
I have a question about the scale up and scale down timeout. So I believe it's only you can do it at one place for the controller manager. You can only, or can you do it per application essentially?
Yeah. So to clarify, for those of you who don't know, there's currently a back off period in the Horizontal Pod Autoscaler that we've had for a while now to work around some concerns about thrashing. And that is currently only configurable on a global basis across your Kubernetes deployment. And the question was whether or not we could do that on a per Horizontal Pod Autoscaler basis. So that's been a common request. And we will probably get around to addressing that eventually. One of the things that we've wanted to do for a while now is to make the algorithm a little bit more intelligent, so that we didn't actually have to have a back-off period at all, because the back-off period is a little bit of a hack. So you may see, we may experiment around with controls on that in the short term, but our long-term goal is just to remove those entirely and make them unnecessary.
Have you thought about using a PID controller for autoscaling?
I have pondered it on a rainy day on occasion. Yes. Which is a humorous way of saying that I haven't gotten around to actually writing the code out and figuring out whether how much added complexity that would add to our setup and the actual mechanics. But I would love to either do that myself at some point or see someone doing a proof of concepts. If you are a fan of control systems and would like to write me a PID controller Horizontal Pod Autoscaler, I will be eternally grateful. But I would like to get around to trying it out at some point eventually.
Hey, if I had multiple external systems that I wanted to query, Sysdig, Datadog, Catchpoint, and they were all feeding various bits of information that I wanted to scale on, would I be able to do that with this current setup, or would I need to provide basically a single system that kind of consolidates all of them and feeds that back into Kubernetes?
You basically need some sort of a reverse proxy adapter, which is basically a single system for now. So we had this request before, and basically external metrics were just added in 1.10, but this is something we are going to consider in the future, depending on how many people want it really.
So for a little bit more detail on why that's not doable currently, without a little bit of extra work. So the APIs that we use, both the resource metrics API, which provides CPU and memory, and the custom metrics API are actually presented as standard Kubernetes APIs. They appear on the API server. You can use clients to get them. You can test them out with curl, /APIs/custom.metrics.k8s.io. And so there's only one instance of each of those under the standard Kubernetes model. So you'd have to have basically a dispatcher. The dispatcher probably wouldn't be too hard to write, but you'd have to have one. And that would be the thing that actually provided the API to Kubernetes, and then other things could just sit around there and somehow be discovered by the dispatcher. Any other questions?
Okay, I think we're good. Thank you.
Thank you very much for coming.